Let us start today's class 6, that is hairbridge. I'm discussing here how the bridge is used and what parameter is measured using this hairbridge. This, see, the limitation of Maxwell's bridge is that it cannot be used for high Q values. The Hayes bridge is suitable for the coils having high Q values. The difference in Maxwell's bridge and Hayes bridge is that the Hayes bridge consists of resistance R1 in series with the standard capacitance C1 is one of the ratio arms. Hence, for larger phase angles R1 needed is very low, which is practicable. Hence, bridge can be used for the coils with high Q values. The bridge, let us see how it can be done. So you can see here the various constants of the bridge and the under balance condition. The phasor diagram looks like this. So Z1 is R1 minus JXC1. You look at the diagram, students. There, where R1 minus JXC1 can be written as 1 by omega C1. So Z2 is equal to R2 and Z3 is equal to R3 and Z4 is equal to Zx, that is equal to Rx plus J omega Lx. Okay, this is about the brief introduction about the bridge. So at balance condition, what happens? So if you want to look at the balance equation, so we'll see that at balance equation, what happens? Z1, you know, very familiar by now. Z1 into Zx will be equal to Z2 into Z3 under balance condition or at the balance condition. So if I derive that, if keeping that in my mind, if I derive, I will get, so in place of Z1, what is there? I have already told you that R1 minus J1 by omega C1 and Zx is Rx plus J omega Lx, which is equal to R2 into R3. So if I simplify that, R1 into Rx minus J Rx by omega C1 plus J omega R1 Lx plus Lx by C1 is equal to R2 into R3. So here equating the real parts of both the sides, Rx into R1 plus Lx by C1, which is equal to R2 into R3. Now if I equate the imaginary parts of both the sides, then I get omega R1 Lx minus Rx by omega C1 is equal to 0. So to obtain Rx and Lx, now the equation by solving about two equations, finally we land up with Lx is equal to what? And Rx is equal to what? So Lx is R2 into R3. So by solving this, you can find unknown equations. L1, you can call this as L1 or Lx. R1 is equal to Rx, what I've used in my, this one, Lx I have used, Lx for unknown, Rx for unknown. So Lx is R2 into R3 into C1 by, this is what the equation I have got finally. This is what the equation I have got finally for L1. So after that Q factor of the coil also we have determined by looking at this, you can see Q factor of the coil. So phasor diagram is written for the, by looking at that, see here, seeing the bridge, we have written the phasor diagram. So writing the phasor diagram, we have taken the references I1 and I3. After taking I1 and I3 references, we have got, first we will find the phasor E1, which is equal to E2, and we find the phasor E3, which is equal to E4. So when we add these two, we get the resultant voltage V, that is E. So this is how we can rewrite the phasor diagram. So after that, what are the advantages of this Hairs bridge? Because each and every bridge has its own merits as well as demerits. So what are the advantages? Is it is best suitable for the measurement of inductance with high Q, typically greater than 10. Secondly, it gives very simple expression for Q factor in terms of elements in the bridge. It requires very low value of resistor R1 to measure high Q inductances. So these are the few advantages what I have listed. Okay. And disadvantages of this one, it is only used suitable for measurement of high Q inductances, students. So for high Q inductances, 1 by Q square term can be neglected. But for low Q measurement, 1 by Q square term is significant. So that's why it cannot be neglected. Hence, Hayes bridge is not that suitable for the measurement of low Q inductances. In such cases, we prefer Maxwell bridge. Okay, that's about Hayes bridge. So let me go to the next bridge, Anderson's bridge. So it is another important EC bridge which is used for the measurement of self-inductance in terms of a standard capacitor. Actually, this bridge is nothing but modified Maxwell's bridge, in which also the value of self-inductance is obtained by comparing this with a standard capacitor. This bridge is basically used for the precise measurement of inductance over a wide range of value. So the Anderson's bridge, what I have shown here in the diagram, you can look here. This what are there are 4 arms in each bridge. In each arm, what are those? So one arm of the bridge consists of unknown inductors, Lx. You can see the unknown inductor L1, or you can call it as Lx with known resistance in series with. Okay, this resistance R1 includes resistance of the inductor alone. So C is the standard capacitor with R, R2, R3, R4 all non-inductive, no resistances. So the bridge balance equations are, see here, the current I1 is equal to I2, I3, I2 is equal to I4 plus IC. So V2 is equal to I2 into R2. You can look at the diagram. V3 is equal to I3 into R3. So what happens to V1? V1 is equal to V2 plus IC into R, whereas V4 is equal to V3 plus IC into R. So like that, V1 is equal to I1 plus R, I1 into R1 plus I1 omega L1. V4 is I4 into R4. Therefore, V will become V2 plus V4, or you can call it as V1 plus V3. Both are true. So to find the balance equation transforming, we have to form a star formed by R2, R4 and R into its equivalent delta form. Okay, that is by doing that, we land up with the equation. When I do that, we land up with the expression of how do you find Lx? Lx is equal to C R3 into R5, whereas R1 you get R3 into R5 by R6. So what are the advantages of this Anderson's bridge? Advantages of Anderson's bridge are it can be used for accurate measurement of capacitance in terms of inductance. And another is the other bridges require variable capacitor, but a fixed capacitor can be used for Anderson's bridge. And one more is the bridge is easy to balance from convergence point of view compared to Maxwell's bridge in case of low values of Q. So what are the disadvantages? So the main disadvantages is in this Anderson's bridge is it is more complicated than any other bridges. So uses more number of components. The balance equation are also complicated to derive. So bridge cannot be easily shielded due to additional junction point to avoid the effects of stray capacitance. So these are the few advantages and disadvantages of the Anderson's bridge. So that completes today's